Present-day sloths are relatively small mammals. They are less than a meter in length, average around 5 kilograms in weight, and spend most of their time suspended from branches in trees. They are currently restricted to South and Central America. Sloths are notable for their low energy levels and slow, deliberate movements. They are part of a larger group known as the Xenarthra, which includes their distant relatives the armadillos and anteaters. In contrast to the present day, most extinct sloths lived on the ground, and some were many times larger than modern tree sloths, such as the now extinct genus of sloths known as Megatherium. With the possible exception of the woolly mammoth, Megatherium is arguably the most famous of the giant mammals that once roamed this planet after the decline of the dinosaurs. It is known that there were around 8 species of these giants, the largest of which was known as Megatherium americanum, which was up to 10 times the size of living sloths, reaching weights of up to 4 tons, similar to a present-day bull elephant. On its hind legs, Megatherium americanum would have stood a full 3.5 meters or 12 feet tall. Megatherium americanum is known from Argentina, Uruguay, and Bolivia in South America. Fossils of the animals have been found in deposits dating from the Middle Pleistocene, around 400,000 years ago, to the beginning of the Holocene, around 8,000 years ago. Its skeletal structure suggests that it walked long distances on all fours to distribute its weight evenly. But its short hind legs and wide pelvis also tell us that the Megatherium likely spent a lot of time standing and sitting back on its hind legs and short thick tail. One interesting characteristic of Megatherium anatomy is their enormous 7-inch claws. Because of their claw length, this giant sloth was unable to walk on the flats of its paws like any other mammal. This would have been another reason they probably walked long distances on all fours. Walking on all fours would have been more comfortable in this awkward walking position. However, even though Megatherium was certainly capable of shifting its weight to its hind legs, and even walking on just the hind legs as indicated by fossil footprints, Megatherium probably adopted a quadrupedal posture when resting and normally walking extended distances. The large claws on its hands and feet meant that it had to walk on the sides, and not the flats of its feet. The Megatherium lived in large groups, though individual fossils have been found in isolated locations such as caves. It gave birth to live young, as most other mammals do, and likely continued living in familial groups while their young matured. One study has proposed that Megatherium was mostly hairless, like modern elephants, because its large size and small surface area to volume ratio would have made it susceptible to overheating. One of the most fascinating things about Megatherium is almost certainly its burrows. Like moles, wombats, and even some bears, Megatherium spent a significant amount of time underground. When the Megatherium burrows were first discovered, they were a complete mystery. Geologists came across several large cave networks in the 1930s in parts of the Amazon rainforest. However, there didn't seem to be any natural explanation for these cave networks. They weren't near any sources of water and didn't seem to be associated with any geological activity. Some assumed they were structures of an ancient civilization or caves made by early human ancestors, but no one gave them much thought. The first paper identifying the true origin of these burrows was only released in 2010. A geologist, Amilcar Adami, started by investigating a particularly large network of the tunnels in the Amazon. Over time, he discovered more and more of these tunnels, which often extend for over 100 meters and are 2 meters high and 4 meters wide. Some even have their own separate chambers that randomly branch off at different points. They were truly immense. It just wasn't plausible that any humans created it, with our level of technology 10,000 years ago. Once Adami observed large claw marks in some particularly well-preserved chambers, it clicked that these were probably the burrows of very large ancient creatures. After further investigation, hundreds more of these paleoburrows, created by different animals of different sizes, was discovered. It's a very obvious answer now looking back on it. Of the mammals alive today, around 3.5% spend almost all their time underground. And about half of mammals spend at least some time in burrows. It's very likely that this was true a couple of thousand years ago as well. And a lot of the animals that were around 10,000 years ago were much bigger than their modern equivalents. So it stands to reason that there would be a whole bunch of surviving massive burrows of extinct land creatures. After the concept was established, another researcher surveyed a 45-mile stretch of highway construction near the city of Porto Alegre and identified paleoburrows in more than 70% of road cuts. Most of them were filled in and much smaller, but they're still very distinctive. There are probably millions of paleoburrows all across the world, created by different creatures at different times, some maybe even being reused by modern species like bears and wombats. It's not really known why a massive sloth would feel the need to burrow underground. Generally, smaller mammals do it to escape predators or keep warm. However, with the size of Megatherium, those things were unlikely to be issues. It's likely that a family of Megatherium would live in these burrows, extending them over generations. Maybe to protect their offspring? A lot more research is needed to answer these questions. The Megatherium had a strangely small head and mouth for such a large animal. In fact, among all other ground sloths that existed during the Pleistocene epoch, it had the narrowest mouth. It was larger in the back and narrowed down to the front in a cone shape. This likely meant that it was much more selective in the foliage it ate. This wouldn't have been a problem because it would probably have reached higher in the trees than any other herbivore of its time. Aside from its large size, Megatherium's skeleton is extremely robust in its construction and seems to be built not just to support its large body, but to provide the maximum amount of stability. The lower bones of the short hind legs are comparable to the femur in thickness and development. Combined with a short but thick tail and a broad pelvis, the lower body basically becomes a seat for which the upper body can rest on. The price of this lower body development is that Megatherium certainly would not have broken any records for speed, and may have been one of the slowest animals in its ecosystem. However, this would not be a problem as Megatherium probably would not have had to run to or from anything. The upper body construction is along similar lines in its robust build, but has more of a focus upon flexibility. The arms are still built solid and strong for weight bearing, but they are also much longer to provide additional reach. This reach would have also been increased even further by the large claws on its hands, allowing taller branches and foliage to be brought down to the level of the mouth. The strong jaw is an adaptation more suited for mashing plant material, though a combination of strong muscle attachment and robust molar teeth. We know that the Megatherium was not a carnivore based on its mouth and tooth structure alone, and it probably wasn't fast enough to be a predator anyway. At the same time, we do not have conclusive evidence that it was strictly a herbivore either. Based on tooth remains that researchers have found, they know that the primary diet of the giant sloth was gritty and fibrous. With that said, it would have very little competition for food, even with many other herbivores around. Not only would it have been capable of eating low vegetation or digging for roots, but it could have reached higher than most other plant eaters. There are also theories that the Megatherium may have also eaten meat to supplement its diet. Some say this could have simply been scavenging animal corpses. However, it also had the size to kill other herbivores. Some of these theories began with Richard Farina, a paleontologist from Montevideo University of the Republic. At one point, he agreed with the common consensus that the Megatherium was a herbivore. However, according to fossil records, the South American steppes, where the giant sloth lived, were home to many herbivores. And because there were very few carnivores present, Farina speculated that the environment couldn't have supported the number of herbivores, and he suspected that Megatherium may have been an omnivore. This isn't proof in itself because no fossil evidence supports it. But it's an interesting theory that the fossil record doesn't deny either. Megatherium inhabited woodland and grassland environments of South America, with a late Pleistocene range centered around the Pampas where it was an endemic species, as recently as 8,000 years ago. Megatherium was adapted to temperate, arid or semi-arid open habitats. The closely related genus, Armadillos, that has been classified occasionally as part of Megatherium, lived in more tropical environments further north, and invaded temperate North America as part of the Great American Interchange. According to much of the fossil evidence, researchers suspect that most of Megatherium likely started dying out around 12,000 years ago, during the end of the Cenozoic era, during the Quaternary period. Most researchers agree on two significant factors to the Quaternary extinction event: climate change and humans. It is likely that it went extinct, mostly due to humans hunting it. Large numbers of Megatherium bones have turned up near human settlements, often with cut marks that suggest the animal was butchered. There are even a few sites where it looks like humans hunted and killed Megatherium by trapping them in a gully, just like we did mammoths and other large mammals. Additionally, in South America, where the Megatherium lived, temperatures would have likely fluctuated dramatically and become colder and more arid. This giant sloth didn't go down without a fight, because we know that it lasted for many more years. The strongest were able to adapt to a certain degree, with the last individuals only disappearing around 8,000 years ago, which is about the same time as ancient civilizations started to appear.